Linux permissions are a funny thing to try and find documentation on online, as it's very difficult to find anything about the last 3 bits. And plenty of people have lots of tutorials on setting the first 9 bits, and those are the most common and most important. But there's an additional 3 bits as well, and to really dive into what's really going on with the permissions, it's hard to find that. But you found it in this video. I'm going to deep dive into Linux permissions. So first of all, permissions. What are they? What are they for? They're for preventing people who are goofing off from goofing up your system. They're a security measure. They're meant to prevent unwanted activity on the file system. Different permission systems that we've had, Linux is kind of in the middle as far as how it's made, as far as how it's structured. One of the ones that's very basic goes back to FAT, file system, where you could set a read-only bit and it didn't recognize your users and anything else like that. It was just unaware. You could set read-only bit, but that was about it. Microsoft Windows has a very detailed access control list driven permission system, which I do have to say, for its capabilities and the quality of that system, it does dust Linux on that. It is generations ahead of Linux. Linux is a middle of the road, but I think it's very, especially when you understand it, I think it's very sufficient for our needs. So Linux is going to recognize things it's going to recognize things as part of 3 different types of users, and how you are defined on that user group. Let's take a look and see our matrix here. So users over here, how does it define if you're a user, a group, or an other for an action that you're trying to do? First of all, we want to look at your user account. Your user account has a user ID, which is a numeric representation of your user for the Linux system. You could change your username, and your user ID should stay the same, because that's where your file stamps are on all your files that you own. You also have a primary group that you're a part of, and any new files that you create, that's the default group that it's going to set as the owner of, as the group on that file. And then you've also got additional groups that a user can be a part of. Now a file has, I guess I'm going to have about 4 attributes that are important for this. The file name, you're going to have a you're going to have the owner, and you're going to have a group. The group, you don't have a list of groups. There's one group for that file. And I was going to mention 4 things. Hopefully I think of the other one as I go on. So owner, oh that's right, and our permissions. That's the other thing. Our permissions is the 4th. Alright, so we've got our, to determine if you are the owner for an action, it's going to compare your owner numeric, and then those are also on that file system. It has a owner ID, user ID for that file, and it has a group ID, which are the numeric representations of the owner and the group. But it's going to compare your owner account versus the owner of that file. If that matches, it looks no further. That means if you are denied as an owner for something, it doesn't look to see if, oh, as a group, are you allowed? As someone else, are you allowed? It's not going to check anything else. It's already failed you. You're done with that action. It's going to deny you at that point. If you fail that owner check, you don't match the owner, then it's going to take a look and see if you are group. And it's going to take a look at your primary group and any additional groups to see what you are a part of. And if you match any of that, now you're group for that action. So if you're trying to, for example, all my actions are listed up here. So if you're looking for examples, if I'm trying to read a file, if I'm denied as an owner, my user ID matches the user ID of that file, and I'm denied read permissions as an owner, it doesn't matter if my group, even my primary group, has read permissions, I'm denied. I don't have access to it. Now if my group, any of my groups, is checking against all of the groups of my user against the group of that file, and if you match on any of those, then it compares your permissions for that action, and if you pass, great. If you fail, you're denied. It does not look at other. If you fail on both of those checks, you fail to match the user. It's not that you were denied access, but you just were not the owner, you were not the group, and I'm using owner and user interchangeably, and there's a reason why. It's because if I try to, O is taken up as other, that's why. So that's why they use you for the owner, user, the user that created it. But yeah, if you don't match those two, then you're classified as other. So that's how it's going to classify you. Now, what are these types of actions that you could have? I was going to get back to the file name real quick. If you have a dot at the start of your file name, it's not really a permission change, it's more of a convenience, but it makes it a hidden file on Linux. By default, it won't show up unless you ask it to. So it could be a security thing that you could use to keep it out of sight, out of mind, but it's not really meant to block particular actions. So your read actions are really to read from the file. That's what you're trying to do whenever you're trying to read from that file. You can always see it, even if you're denied, even if everyone's denied read permissions, you can always see that that file exists. You just won't be able to pull content out of that file. How about write permissions? That deals with any type of changes to the file. Renaming, appending, rewriting. If it's a directory, the write permission would prevent you from being able to write into that directory, from creating a new file in that directory. In order to all directories, you need execute permission to work with a directory. For whatever reason, you need the execute permission to work with a directory. But an execute really is to tell it to execute in a way that you won't see that. So let's take a quick look at execute permissions over here on my examples. I have up here in the upper right corner, I have, this is one way to call a PHP script, and then another way would be to set it with a hash bang that goes to an interpreter and setting the execute permission. So in this case, PHP, in both cases actually, because in this case we're using PHP as the interpreter. That's just our example. If we're using something different as the interpreter, whatever your interpreter is, needs to have execute permissions. This is what we're executing here. And when you execute a program, it is by default running as the user that started it, unless it's running as your user and it's running as your group. That's by default what we're doing. We can change that as we're going to look at set user ID and set group ID permissions. So PHP needs execute permissions in this context and down here. However, up here, PHP is started, it's running as my user and group. My user, or anyway, PHP as my user is now going to try to read this for me. Everything an executable does, it does on my behalf. So that's the point why it takes by default that user and group ID. And if you set user and group ID bits, then that can change which user and group that executable is running as. But in this case, we have our script here. So this is going to be read by PHP to be run. Linux is going to recognize this only as a read action. It's not seeing this as an execute. It doesn't care there's executable code in here. We have an open file for reading request by an executable, because it's got to read it in to be able to interpret it. The PHP interpreter is trying to grab the content. So this is a read. I don't need any execute permissions on this script to run it this way. I do need read permissions. Down here, this particular script, to be able to run it with just the command style, the ./script, if in this case, this is my command. So it's now being told to execute that file. I only need read permissions if I want to be able to see the source code. But to run this file, I do not need any read permissions at all. But I must have execute permissions. So this is execute permissions only, this is read permissions only, and PHP in both of these would need execute permissions. Does not need read permissions for either one of these two examples on PHP, on the PHP executable. So that's how that's how we determine the difference between execute and read in detail. Now let's take a look and see also directories here. Now user, group, and other people. Whenever you see it in the directory, you'll either see a dash or you'll see one of these characters, or possibly if you've got special bit set, you'll see some other symbols. So this is all for the owner. Can he read, write, execute? The group, read, write, execute. And the everyone else, read, write, execute. Now, these guys are going to get overwritten with these guys here. So, is it set user ID? Is this set group ID? This is going to be an S. If it's set user ID, this is going to be an S. If it's set group ID, this is going to be an S if we're sticky. Those are three different other permissions. So, set user ID is really used for executables, and it means that it will run as the owner of the file, not as the caller. So if you're calling a file, the one that's commonly used as an example here is the password changing script in Linux. Has this. It's owned by root. You have permission to execute it, and when it runs as root because that bit is set. So yeah, that particular that bit can change. You know, you can say, hey, I want everyone else to be able to run this, but not as themselves. They're going to run it as me with that special permission set. They're running it as me, as the owner. And same thing with the group, can also work with executables that way. Now these other two guys are for directories. A sticky bit means only the owner can delete files from that directory if the sticky bit's set. The group set group ID for a directory will make it so that new files added to that group get their group ID set to whatever that directory's group ID is. It's it takes that group ID from the directory and applies that to any new files created. So those are special permissions, and we'll talk a little bit more about how to do the changes here in a moment. So actually we got some examples up here, and then we'll take a look down here and I'll explain those once we've explained how to figure them out. So there's two main different, actually there's three ways, but there's two main ways: symbolic and numeric. And there's your basic numeric, which means you've only got 3 digits on your chmod, which looking over here, we have, this is a format for a chmod command. We'll just go ahead and take a look at that. So chmod is the command you'll use to change file permissions. You'd use chgrp, and this would be in here, would be your new group to change the group of a file, and chown would change the owner, and those are more root based. For chmod, you can be root or the owner of the file, but if you're in root, you can change owners and change groups using chgrp and chown. But this is chmod. So this is the basic numeric, which is just 3 numbers in here, and we'll explain how to calculate those on the next when I go into my explanation for that. And on here we can have multiple files just separated by spaces. Same thing here, we can have multiple files separated by spaces. You can even use like patterns as well. So you can say like everything in this directory, change it. And here we've used the 4-digit number format, which we'll also explain how that's done as well. And we could also add multiple files to this. And this is our symbolic system, where we have chmod and then our symbolic stuff in here, and then lists of files. And here we have them numbered. I'm sorry, these are symbols and comma separated for groups. I'll explain how we do that grouping too. So let's take a look. For the symbolic, that's what I've got these critters up here for, but you've also noticed that there's an A, and I don't have an A over here. The A is for all. That's going to mean it's going to set owner, group, and other all at the same time. So if I want to say chmod, let's say I just wanted to set the user and the group permissions, I would just say chmod ug and then whatever operator I want to in here, and then whatever permissions. And then if I wanted to set everything on at the same time, there's that shortcut to just say A. I want to add read permissions to everyone. So chmod space A plus R. So these are the types of permissions that you'll see. These are the common permissions, is R, W, and X for read, write, execute. And that's what you're going to put over here, and we'll explain the S and the T shortly. So yeah, let's take a look here, and we've got so yeah, we've explained U, G, O, A. And so the operators. Equals means I'm going to set these permissions. I'm going to make it so that these guys, I'm making them equal these permissions as I'm setting them. To use plus means I'm just going to be adding certain permissions. And then to use minus means I'm taking away permissions. Say I don't want everyone else to be able to execute this anymore. Chmod space O minus X space file name. So we've got the who's in here. We've got the operators and read, write, execute. But now S and T. S applies to U and G. That's for setting your set bit, set user ID, set group ID. That sets that user ID and group ID special permissions, respectively. So if you used chmod U plus S, you just set the user ID. If you set chmod G plus S, you just set your group ID. So it's going to matter on this S, it's going to matter which of these two who's that you used as far as which one you're setting. O doesn't mean anything on that. Now, if you're using O over here, the only one that's really going to apply as far as your specials is your T, which is for your sticky bit. So we can see it in here too. You know, we have a reminder here. This is for user sticky, or I'm sorry, user set ID. Group can be set ID, and then the everyone else other sticky bit. So that's where we have the symbolic. And so we can also say, I want to make multiple modifications at the same time to this group of files. I want to add, well, let's take a look over here at our sample here. So I have two of my programs, and I wanted to add execute permissions to the owner and read permissions to the group. I can comma separate those groups, but whenever I get over here into files, I need to space separate those. So they're comma separated as far as permission groups that I'm working with on that. So now let's take a look here at long numerics, basic numerics first. First of all, basic numeric, and that's where we need to take a look at the matrix here, okay? We first calculate our user, and then we're going to calculate our group digit, and then we're going to calculate our owner. That's what those three digits that we see over here are. So this is the owner, this is the group, and this is everyone else. And what permissions do they have is set by that numeric. And you're just going to add the permissions together, the values of the permissions. So a read permission is a 4, a write permission is a 2, and an execute permission is a 1. Total up what you want, don't total up what you don't want, and there it is. That's going to be your digit, and you just do that across user, then group, then other. Now, what about our long numeric? We have one more digit that we add. We're going to append everything we did up here at the basic numeric on the end of that. But the first one, we're going to add the set user ID would add a 4. That's where we have our number here. But set group ID, we would add 2. And set our sticky bit, we're going to add 1. Add up whatever ones you want in here. So add 4, add 2, add 1, as you choose that you want these different features. And being that being that not everything can support each one of those, it doesn't really make sense to make that a 7. If you get a 7 out of that, check what you're doing. Group ID applies to executables and it applies to directories. Sticky applies to directories only, and set user ID is only to executables. So if you're getting a 7 out of that, check your math. But you're going to calculate those numbers, and then you will create that number, and then whatever files that's going to be, whatever file names you're going to be modifying with that. So hopefully that was a very good explanation for all of our permissions in Linux and how exactly to use them, what they mean, and how to modify them at your leisure. Thank you for watching.